Okay, so trig identities, what we're looking at here is we're thinking about the first thing you need to do is think about the unit circle. That's kind of where trig identities all start. So if I threw a point out here, 1 unit away, okay, it's going to be some value of x, some value of y, and then 1. We'll call that the radius, but think of that, the radius equals 1. Okay, so if we're making sine in terms of y and r and x, it would be opposite over hypotenuse. This would be adjacent over hypotenuse and opposite over adjacent. Now cosecant is the reciprocal term of sine. This is 1 over sine, or r over y. Okay, this is 1 over cos, or over x, and this is 1 over tan, and that is x over y. Now those are helpful when we start to do like half-angle identities. We need to be able to think of it in terms of x, y, and r. But for now, really what we need these for is this next identity. So the reciprocal identities that you're going to need to know, and you should have these memorized, are these 3. Okay? So 1 over sine goes with cosecant. 1 over cos goes with secant. 1 over tan goes with cotangent. If you think of a CS pair, sine and cosecant, cos and secant, they both have a C, they both have an S. And then cotangent and tangent just go together. Okay, the next thing that we're going to look at, so if we put this next, so sine over cos, in terms of x, y, and r, well, sine over cos is y over r. Now I'm going to write it like this, because now we've got x over r, so we're dividing by x over r, because that's cos. But y over r times, we always multiply and then flip the fraction, we end up getting this, which is y over x. Okay, well y over x, that's actually equal to tangent. And that's our next identity. Our next identity is the quotient identity. And the quotient identity is tan theta is equal to sine theta over cos theta. Now, you're probably saying, Mr. Shaw, why are we doing this? Well, we're going to get to that. Now, the next identity, sine is again y over r, and we're squared here, plus x over r, again squared. And we know that r is equal to 1, so this is y squared plus x squared, because we told you r was 1, we're talking about the unit circle. Well, if I look up here to that triangle, if I was solving for r, we know r is equal to 1. We do Pythagorean theorem. We do x squared plus y squared equals r squared. Well, x squared plus y squared in this case is equal to 1, because 1 squared is 1. So what this is telling me is that this whole thing down here actually equals 1. Well, that's our Pythagorean identity. So the Pythagorean identity is sine squared plus cos squared equals 1. Now we can rearrange that to sine squared equals 1 minus cos squared by subtracting the cos squared over, or cos squared equals 1 minus sine squared. Now, why do we need all of this stuff? Why did we just go through and find all of those things? Why on this page am I giving you what are called the double angle identities? And all of these are just derived from using triangles and using these identities here that we've just talked about. Okay, you're not going to have to memorize these. These will be on your IB formula sheet. But what they're doing is they're helping us prove certain other identities or prove other things to help us solve trig equations. Okay, we can only solve a trig equation typically if we have one function that we're looking at. We can't solve something like this equation here that has sine x, cos x, and tan x all equaling 1. So what we need to do is either prove the identity or rearrange the identity so that we can have an easier solve. So when we're looking at something like this, what we want to do is separate left side and right side. This is the only way really to do it. You have to separate, kind of like a formal check. You have to look at the left side independent to the right side. The next thing is we're going to work down. And if you get stuck on one side, you can start working on the other. And then the final thing is statement. You're solving after you've reached your goal. Okay, so we always want to start with our work by making everything sine and cos. There are a few occasions that you can make things into tan, and it will make it easier. But I would say probably 90% of the time, if you change everything to sine and cos, you will be able to work through this. So this first one, it's kind of easy at the start, but you need to recognize things. Like cos x, I'm going to write this out in a couple of steps here. We could probably leave some. But this step you definitely don't need, but I want you to recognize that these are the same things. Okay, cos x times tan x over sine x is the same as cos over sine times tan. Well, now from the quotient identity, we know that tan x is actually equal to sine over cos. Well, sine over cos, I can cancel my two sines, cancel my two coses, and I'm actually left with 1. Okay? And my right side was equal to 1, so therefore left side equals right side, and therefore cos x tan x over sine x equals 1. Okay, let's try the next one. So looking at this next one, a couple different things you could do here. I'm going to start on the right side here because I do think it's a little easier. So we have right side equals cos x times sine squared x over cos squared x equals, one of the coses will cancel with that. We get sine squared x over cos x. Now if you don't see that the answer is there, we could actually work down the left side. This is sine x times sine x over cos x, which is sine squared x over cos x, and therefore left side equals right side. Therefore, sine x tan x equals cos x tan squared x. Okay, so we're proving some identities here. This is like the introductory to proofs that you're going to see in math. Okay, let's keep going. Quickly on this next one, I'm going to use my reciprocal identity to say that this is 1 over sine squared, because c and an s have to go together. So I know that cosecant is 1 over sine. Then I'm going to look at my left side, and I'm going to have 1 over 1 plus cotangent is the opposite of tangent. If tangent is sine over cos, cotangent is going to be cos over sine. Now you're going to say, why did I do that 1 over 1? Well, the only way to put two things together that have a fraction is a common denominator. So I'm going to change that 1 to sine squared over sine squared. And then that's going to be plus cos squared over sine squared. And now I'm going to write this step out, which you typically wouldn't need to write. It would be assumed. But I want you to see it. Now we've got sine squared plus cos squared. Well, sine squared plus cos squared is the Pythagorean identity. So we know that that is actually equal to 1 over sine squared. Therefore, left side equals right side. Therefore, 1 plus cotangent squared theta equals cosecant squared theta. All right, let's try this last one. So the last one, I'm going to change the right side here. I know the right side is actually just sine squared. Now that might not be easier, but now I can look at either this or this. Okay, so the left side, now I changed the right side using the Pythagorean identity. The left side, we have cos x, or sine x over cos x, and then times cos squared, oh, I keep doing theta, x, and then now my two coses cancel, and I have sine squared just like I thought. Therefore, left side equals right side. Therefore, tan squared x cos x equals 1 minus cos squared x. Really, the only way to see some of the tricks is by practicing. Trig identities is something that some people are really frustratingly good at, and some people need to just drill, drill, drill. The more practice you do, the more different tricks you'll see when you're doing the questions. The questions, again, are at the bottom of the page there.